equation of the tangent plane. Now let's say a sphere. We already know what it is. Let's look at a point on the sphere. Now let's say a line through this point touching the sphere only at one point, or at only if the point is P, at only P. Now this line is called the tangent line to the sphere at P. On a point on the sphere there can be infinite number of tangent lines in different directions. All the lines, or all these lines, lie on a plane called the tangent plane of the sphere at P. We can define this as the locus of the tangent lines at a point of the sphere. Okay, now a normal would be what? A normal to the surface of a sphere at P is the line through P and perpendicular to the tangent plane at P. Try to visualize this. One way of thinking of this is, imagine you have a sphere. Okay, let's say a globe, tabletop globe. Now you take that and keep a sheet of paper on that, and you will notice that the sheet of paper touches the sphere at exactly one point. That is the tangent plane. So the sheet is the tangent plane. And normal would be what? Normal to the surface of a sphere at P is a line through P and perpendicular to the tangent plane at P. So let's say this is the sphere, this is the sheet of paper, right? So this is the globe which I was talking of, and this is the normal, and this is the tangent plane. Now let's look at all this analytically in terms of equation of the tangent plane. Okay, let's say the sphere is x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d equal to 0. Okay, P point on the sphere is let's say x1 square plus y1 square plus z1 square plus 2ux1 plus 2vy1 plus 2wz1 plus d equal to 0. Line through through, let's say this is P, through P is x minus x1 by L, y minus y1 by M, z minus z1 by N. Any arbitrary point on this line would be is equal to R, let's say. So x minus x1 equal to LR, x equal to LR plus x1, y minus y1 equal to MR, which implies y is equal to MR plus y1, z minus z1 equal to NR, which implies z is equal to NR plus z1. So the coordinates of this arbitrary point would be LR plus X, MR plus Y1, X1, and NR plus Z1. Let's say this arbitrary point is A equal to. Now, if A also lies on the sphere, then what? That means LR plus X1 square plus MR plus Y1 square plus NR square plus 2U LR plus X1 plus 2V MR plus Y1 plus 2W NR plus Z1 plus D equal to 0. This would be the equation. Okay, now let's open it up. L square R square plus X1 square plus 2LR X1 plus M square R square plus Y1 square plus 2MRY1 plus N square R square plus Z1 square plus 2NRZ1 plus 2U LR plus 2UX1 plus 2VMR plus 2VY1 plus 2WNR plus 2WZ1 plus D equal to 0. Okay, now let's do some grouping. Okay, so L square R square plus M square R square plus N square R square. Okay, here also R square is common, so let's take it out. L square plus M square plus N square. Okay, 2LR 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 X1 plus U. Similarly, 2MR and 2MR. So 2MR Y1 plus V plus 2NR Z1 plus W. Then what else is left out? X1 square plus Y1 square plus Z1 square. X1, Y1 square and Z1 square. Okay. Then we have 2UX1 plus 2VY1 plus 2WZ1 plus D equal to 0. Okay. Now, if you notice this entire thing, we have seen that this is equal to 0. Yes, where have we seen that? Yes, point on a sphere. This is 0. So this we can strike it out. So we are left with R square, L square plus M square plus N square plus 2LR. Okay, since we are doing it, we might as well do some simplification. So 2R, R is common to all the three. So 2R LX1 plus U plus Y1 plus V, and here you will have M plus N times Z1 plus W is equal to 0. Okay, this will be 2M. No, 2 is already taken. So here also 2. Okay, this looks like a quadratic equation, right? R square and R. And remember, we are talking of a sphere, right? So, and a line which touches the sphere only at one point. And if you look at this part of the sphere, this is like our parabola, remember, which is touching the x-axis. And you might have noticed that when a parabola touches the x-axis at only one point, then the roots are 0, right? So usually in a quadratic you will have two roots. Now in this case both the roots will be 0. So that means this will be 0 and this entire thing will be also 0. So that implies that 2 are Lx1 plus u plus y1 plus v m plus n z1 plus w is equal to 0. Now we need to get rid of L, M and N. Now how do we get rid of it? Remember in the beginning we did something like this. We said x minus x1 by L equal to R. Remember this? Now if you want to get rid of L, you have to write it this in terms of L. So L would be equal to x minus x1 by R. So keeping this in mind, our expression will become x minus x1 by R x1 plus u plus m will become what? X minus, no, not x, y minus y1 by R y1 plus v, and n will become what? Z minus z1 by R z1 plus w equal to 0. Now this, if we take it to the other side, that becomes 0, so we can ignore it. Now let's simplify this. X minus x1 times x1 plus u plus y minus y1 times y1 plus v plus z minus z1 times z1 plus w. And remember, LCM if we take, the common denominator would be R, and R if we take it to the other side, it will become 0. Okay, let's simplify it further. x1 plus ux minus x1 square minus again ux1 plus y1 plus vy minus y1 square minus vy1 plus z1 plus wz minus z1 square minus wz1 equal to 0. Now this implies x1 plus y1 plus z1. Let's group it. Ux plus vy plus wz. Now the negatives we can take it to the other side. So this becomes x1 square plus y1 square plus z1 square plus ux1 plus vy1 plus wz1. There is something missing in this. We want 2's here. 2ux1 plus 2vy1 plus 2wz1. That looks like something familiar. So how do we get that? Let's add ux1 plus vy1 plus wz1 to both the sides, right? Let's see what happens. x1 plus y1 plus z z1 plus ux and ux1. So u is common, x plus x1 plus v y plus y1 plus w z plus z1. Okay, this becomes what? X1 square plus y1 square plus z1 square plus 2ux1 plus 2vy1 plus 2wz1. Sorry, we have to add plus d also, because d also seems to be missing to make it a familiar kind of expression. So which means on this side also you will end up with a d. Let me push this a little bit back. So I will have w z plus z1 plus d, and I will have plus d. Now look at this. This looks very familiar, right? So what is this equal to? It is equal to 0, which means we can strike it out. So we are left with x1 plus y1 plus z1 plus ux plus x1 plus vy plus y1 plus wz plus z1 plus d equal to 0. So this is the equation of the tangent plane at x1, y1, z1 to the sphere. Okay, and this point x1, y1, z1 is called the point of contact, right? So if we go back to the picture, this is the point of contact. Okay, I think that's enough. Bye for now.